Hello, good morning, PyParis. As you might have heard, I had some technical difficulties with my projector, with my computer today. I will say that if technology always worked as we expected it to, we would all be out of jobs. So that's okay. We got myself set up. Sorry if I'm a little tired this morning. I am a little bit jet lagged. It is, I think, about midnight, 1 a.m., where I came from. Yeah, from Portland, Oregon. So I came very far to come and talk to you today. The slides are available at this link if you'd like to follow along. And I have something to ask you all today. Let's try something a little bit fun. If you're learning something new today or you're excited about anything you've heard at this conference, please share a tweet on Twitter. The hashtag for the conference is PyParis. If you'd like to @mention me, my username is NNJI. That's like ninja without the I. And let's dive in. Today, I'm going to talk to you about one of my favorite topics, technical debt. My name is Nina Zakharenko. I'm a cloud developer advocate at Microsoft, focusing specifically on Python. That means that my role is to make Azure a pleasure to use for Python engineers everywhere. I've been a software engineer for over a decade. I've worked at a few companies that you might have heard of, like Reddit, Meetup, HBO. But these days, my passion is in Azure. I've worked professionally in about 5 different programming languages, but Python is still my favorite. While I've been at these companies, I've seen some things in the code that were a little bit scary. I'm sure you all have too. So let's talk about technical debt. What is technical debt? Technical debt is a series of bad decisions that are both bad business decisions and bad technical decisions that lead to code that is error-prone and architecture that is error-prone as well. That means that you're using a lot more resources to accomplish less. You kind of want to ask yourself, in layman's terms, what decisions were made in the past that are preventing me from getting things done today? What's the cause of this technical debt monster? Spoiler alert, it's me, and it's all of you. If you've ever written a line of code in your life, chances are you've introduced some technical debt into the code base that you were working on. I made a lot of mistakes early on in my career as a programmer that contributed to technical debt. Things like not seeing the value in unit tests. I mean, why add unit tests? It works, doesn't it? There's nothing else to it. I didn't know how to say no to features. The project lead would come to me with a lot of excitement and say, you know, sometimes we need to add this new thing right away. But sometimes that wasn't fully thought through. Occasionally, it was a lot more work than what was initially scoped out. And as I progressed in my career, I've had an easier time pointing out these things and saying no to them. So let's try to think things through before we wedge them in our code base. Some other mistakes I made early on, my estimates were too optimistic. They didn't include the time that it would take to refactor, to add unit tests, to clean up my code. My priorities were always pushing code through first. I didn't care if the design was good or if it was reusable. I wanted to be seen as a good developer that shipped code on time. This is not the way to do it. I've learned the error of my ways, I promise. Other things that can cause technical debt is just being in a huge time crunch. So just get it out there, get it working. I'll say, I'll take a shortcut and I'll clean it up tomorrow. Who here has said that before? Show of hands. Yeah, everybody. Okay, one more show of hands. Who follows through on that statement? Nobody. Certainly not me. I didn't raise my hands. So if you're going to say that, do try to follow up, but the better position is to just not find yourself in that circumstance at all. Just don't say it. Try to do it right in the first place. Sometimes I'll find code bases that have a lot of unneeded complexity. So you have to know that lines of code committed does not equal the amount of work that you've accomplished. I've worked with developers who've had this philosophy. Some people think, if I come up with a simple way of doing it, then I just haven't provided any worth to this project. If it's too simple, I must have missed something. Well, you know what? Simple is good. It's good even for yourself. When you come back to your code 2 months later, that's going to be a lot less time that you need to ramp up and remember what the code is doing or what it's for. Another cause of technical debt is a lack of understanding. So who's been in this position before? You have a problem, you look up the solution on Stack Overflow, you copy and paste it in your code. You don't really know what it does, but it works. But now you have bugs. I've done this, for sure, a million times. So if you do this, you're going to have a really bad time because introducing code that you don't fully understand is kind of a ticking time bomb with undesired consequences. If you paste from Stack Overflow, try to make sure you take the time to process that code and thoroughly understand what it's doing. Tech debt will cause a culture of despair. You might think that this code base is already a heaping pile of trash. And who's going to notice if I put this one last broken bottle on top of it? Maybe it was like that before you got there, but you don't have to be the one to keep piling on. You can feel empowered to be the change that you want to see. So some red flags. How do you know you have technical debt? Code smells are a good indication. Code smells are not bugs, but they tend to be an indication of a deeper problem. Some examples here are duplicated code, very long methods or large classes, contrived complexity, like I mentioned earlier. It makes code very difficult to follow. Try to stick with simplicity, and don't make things more complicated than you need to. Some more code smells, half-implemented features. Someone thought we needed that one time, and they put it in the code base, and they never took it out. The code is still there. So every time you go and read this piece of code now, you're bogged down with information that's completely irrelevant to the task at hand. It's cognitive overhead that you don't need. Another code smell, no documentation or poor documentation. Maybe HR forced you to hire a rock star, and now they're breaking guitars in your office. And you're stuck with their destructive behavior. Not having documentation means that your code base is not optimized for teamwork. Having documentation is really crucial. More code smells, commented out code, wipe it out. That's what version control is for. Incorrect comments, so maybe you're skimming through the code to get an idea of what it does, and you might read a comment and get a completely wrong idea of what's going on. Broken tests are much worse than no unit tests at all. It's negative reinforcement, and it breaks your continuous integration process if you have one. It's very easy to find deleted code with Git. With the first Git command here, you can search for a regular expression in the code, even in commits where you've deleted that file. The second command, if you know the file name, you can look for it with a git log, and the important thing here is passing in D to diff filter to search for deleted files. That means that you should not have any more commented out code in your code base. If you have it, take it out with a commit, and if you need it, again, you can find it later. Okay, you're asking yourself, how bad can poor documentation really be? Let's take a look at this code. We're a pizza shop, and we pride ourselves on serving healthy, organic, bio food, right? We're for a health-conscious community. So we make sure that we only use the best organic, gluten-free pizza dough. If we look at this method, we'll see that's exactly what the doc string says. I haven't heard any laughs yet, so nobody's figured out exactly what this code is doing. So if you scan further down, you'll see that our code has changed. We ran out of the organic stuff yesterday, so I'm just going to comment out that line and substitute it with a processed GMO pesticide pizza dough instead. We don't want to stop serving pizza, so I'll just slide that in real quick. Okay, if you do this, you say you'll fix it tomorrow and you never do, you might end up with some pretty angry customers. And it's really not entirely obvious on the first read through, right? You're reading the doc string, it says what the method is supposed to do, but it doesn't. It's easy to skim over. Okay, architecture and design might also have some smells here. If you have parts of the code base that nobody wants to touch, that's a good indicator. Like, you couldn't pay me to work on the core. I see some smiles here, some knowing smiles. A brittle code base, so if you change code in one place, it breaks something completely unrelated. If you have severe outages, nonstop ringing pagers, also a good sign that you have some smells. So good design means that it's easy to implement features most of the time. Poor design, you feel like you're just shoehorning in those new features. It's hard and introduces bugs. This isn't the rule all the time. I would say this is an 80-20 rule. If 80% of the time adding new features is easy, you're probably doing something right. So let's talk about Python-specific smells. Okay, functionality changes, but variable names don't. Python is a dynamically typed language. A variable can contain anything, but if you change how a piece of code works, make sure you go back and rename variables to be how you would expect them to be. So in this case, you're expecting a single item in a collection, but actually what you're getting is a single letter from a string. This can cause really subtle bugs that are hard to find, and they're tough to catch on one read-through. Monkey patching, who's done this before? I have? Yeah. Okay, who's done this before outside of a unit test? Oh, no. Oh, no. So monkey patches is when you're making changes to a module or a class while the program is running. Try to avoid this as much as possible. It introduces a lot of subtle bugs. If you're using this outside of unit tests, like if you're patching a third-party library that's broken, really try to reevaluate while you're doing that. Decorators are incredibly powerful, but they can also mess with anything that's passed in or returned from a method. In this example, I've created a decorator that takes your function and it just returns false all the time. It's my evil decorator. When I decorate my function with it, that returns the sum of A and B. I call my function and get a totally different result than what I expected. And that's because my function now always returns false because of my evil decorator. Oops. Most decorators that you come across are probably not evil, but if you're using one that's outside of a known library or it's part of a code base that you're working on that's homebrewed, make sure you check out your decorators, check out the source code so that you know and you're aware of what's going on. Circular dependencies can be pretty bad. Sometimes in Python 2, I've seen people try to get around them by importing inside of a method instead. So it's pretty bad. If it's gotten to the point where you're doing method level imports just to avoid circular dependencies, it's probably time to refactor your code base a little bit and move files around. Could be an indicator of a serious problem. So let's talk about some real world case studies. In my over a decade of experience as a developer, I've worked at companies big and small, and some of these might have been things that I've seen in real life, but I won't name names between us. First, if you live in the US, you might have done your taxes a few years ago. In the US, we have something called the IRS, the Internal Revenue Service. And a fun fact, in 2015, the IRS chief said that we have applications running when JFK was still president. That was 50 years ago. If you had a frustrating experience doing your taxes, that might be why. But he says, and we continue to use the COBOL programming language. It is extremely difficult to find IT experts who are versed in this language. Is anyone surprised they're having a hard time finding COBOL programmers? I'm not, no. But it's not just the IRS. Banks universities, air traffic control, all over the world, they all have systems that still use COBOL. I like to think that these institutions are a little bit important. They're kind of important, right? But they're still stuck using COBOL because they're in too deep. And COBOL developers are becoming increasingly rare. So a little bit of a story where I've seen some of these things. I used to work in finance, and while I was there were many major banking systems that were still running on mainframes. The bankers wanted a UI to take advantage of some modern marvels like copy and paste, having undo functionality, the ability to select text or search with wildcards. Technology that's been around for a few decades, but bankers dealing with these huge sums of money didn't have access to it. So some very highly paid architects had a big idea. They said, let's write a fancy new web front end, and it's going to do all of the things, absolutely all of them. But there was a problem. They had too much technical debt, which meant that at the time they thought rewriting the backend would be too expensive. And we already have these mainframes and COBOL programmers. The mainframe already does what we need. So let's leave the mainframes as part of the equation. So they decided to use something called cursors, because the problem here is you can't query a mainframe with a RESTful API. If you use DB2, these are not the same cursors. So the way that these work, the mainframe would output a text screen based on a result, and the results would then be parsed by reading in the output of the whole screen and parsing variables based on their position in the text output. So for example, line 5, column 80 would be the amount. I hope none of you have heard of this concept before, because it's truly awful. So what was the result? The result was that the system was incredibly slow. The mainframe itself was pretty fast, actually, but the bottleneck was you're waiting for results to be printed on a terminal somewhere, and then you're taking that output and you're parsing it. Very, very error-prone. If you expected the output to be on line 5, column 80, and instead it was on column 81, everything broke. Not only was it slow, it was also very brittle and error-prone, and the bankers hated it. So, after months and months of work, this multi-million-dollar project was completely scrapped. So you can try to cover up debt in these ways, but it probably won't work. If you're going to try to tackle a massive technical debt problem, do it right or don't do it at all. This isn't just a problem that affects these big conglomerate corporations. I worked on a project I'm going to call the MVP. MVP stands for the minimum viable product. That's when you have a product, you really want to get to market, so you hack it out, you do it, whatever you need to do, get it to market as fast as possible to test if your assumptions about the success of this product will be true or not. Turns out the product was actually a great idea. But the problem was that the core code base was created by a lone developer in this 48-hour coffee-fueled haze. And they didn't have a long-term plan. There were no tests. There was no proper design decisions. Because it was a great success, though, this stuck around. In fact, a whole company grew out of it. But there was a problem. Years went on, but the initial code base and the design didn't go away. Everything in the project that was new were based on those decisions made in those initial 48 hours. And worse, because we were this growing company, there was never any time to refactor. The push for new features was so strong that while the technical debt was just growing exponentially, we kept sweeping it under the rug, because if nobody talked about it, that meant it wasn't there, right? But we ended up with some scope creep. The code base, because of all the issues mentioned earlier, the code base was incredibly complex for no good reason at all, really. There were a lot more working parts than necessary. And the features that were a good idea in those initial 48 hours stuck around forever, just in case we needed them later. And spoiler, we never did. The result of this was some pretty sad developers. There were minimal working tests, there was no time to write them, and they were not part of the culture. During every release, something was bound to break. And worst of all, that made those project failures feel like it was your fault, even when it wasn't. That was not exactly great for morale. So what happened to this project in the end? Well, it ground to a halt because development time for new features skyrocketed. We had to battle the existing design every time we wanted to implement a new feature. And the project was deemed too difficult to maintain and was eventually canceled. Moral of this story, sometimes you just need to burn it. Burn it with fire. Some projects get to a point where there's just no saving them. Just rewriting part of the system or scrapping it all, if it becomes unmaintainable, is what you need to do. Sometimes that's the only way that a software project can be saved. This is a really tough sell. But if you take the time to create an estimate, if you evaluate technical options, if you work on a better design, cut features, update technology, you might be surprised by how little time a rewrite will take compared to how bogged down you are with the current system and how long it takes to implement new features. I will say that projects really rarely get to this point, but when they do, you should know when it's time to walk away. Okay, that's a lot of doom and gloom, right? I'm sorry. But let's talk about how we battle this technical debt monster and how we can come out ahead. Okay, first, we don't point fingers. If Joe was the source of all that technical debt and he quit 4 years ago, well, you can't really blame Joe anymore, right? You've been maintaining the system the whole time he was gone. But if Joe still works with you, you still should not point a finger at him because technical debt is a team-wide problem. And everybody needs to be a part of the solution. We all own the code base. So work together to create a style that everybody agrees upon, have code standards, because I like to say that an elegant code base is one that was worked on by multiple people, but looks like it was written by a single person. Pair programming here is huge. When you're working on something, sometimes you think, oh, that's a bad idea. I'll just sneak it in and forget about it. If you're pairing with someone, it really keeps you honest. You have someone behind your shoulder tapping on it saying, well, hey, actually, that's a bad idea. Don't do it. Code reviews help a lot here as well. So that style guide that you set up during the code review, you can say, look, we agreed on these standards and you're not following them. Let's work together to fix that. Unless something is on fire, if possible, every line of code that gets merged into the master branch should get looked at by at least one other pair of eyes. You might say, well, if something is on fire and I have a production bug, I can't wait, I just need to squeeze this in and fix it. Well, I would say that most times when you're harried or you haven't slept and you're trying to patch something last minute, you might break it even worse. So when something is on fire and going wrong, that's, I would say, one of the best times to have somebody else looking at your code. You really need to be accountable. So unit tests and integration tests are incredible here. I consider myself to be a good programmer, a careful one, but I'm still surprised by the amount of typos and syntax errors and various things that are caught by unit tests and integration tests. This is especially important if you're working in a dynamic language like Python. You could have issues with similarly named variables or small, stupid, potentially explosive bugs. But remember that unit tests don't do anything unless you actually run them. Don't forget that step. try to set up pre-commit hooks for your repository. If you're running pre-commit hooks on the code that you're trying to commit and that hook fails, you can't successfully create the git commit. So you're preventing that code from even getting pushed upstream in a commit. Pre-commit hooks can test for lots of things like errant debugger statements, PDB or IPDB statements, unused imports. You can even do things like check the validity of JSON and a lot more. There's an awesome site here, pre-commit-hooks.com, with a lot of pre-baked pre-commit hooks. Also, continuous integrations. There are lots of options here. Circle CI, Travis, Azure Pipelines are an amazing product. Any of these options integrate with GitHub. And when you start a pull request, you can see the build status of your PR right there. If your test pass, did your integration test pass, did your code linting rules pass? Rule of thumb here, if CI fails, don't merge it into master, ever. You can even set up GitHub to block those types of merges. Okay, another company I worked at, I had a very strange first day orientation. The senior architect that was doing our onboarding gave a presentation titled, "Why have one thing that does something when you can have two things instead?" I was scratching my head a little bit. This code base had everything in it. It had Mongo, Cassandra, Django templates, MySQL, Node, Memcache, really, like the whole kitchen sink. Oh, and Redis. I forgot Redis. One last thing. Early in the project, some engineer would think this technology was a great idea, toss it in, and then that person that became the de facto expert, he would quit and would make it somebody else's problem. So they wanted to cut down on technical debt, but they never committed enough time or resources to actually get it done. So they ended up with twice as many technologies in their stack as needed and twice as big of a mess, because someone would start the process of migrating off one of these technologies that was no longer needed. But one of the product folks would step in and he would say, well, or he or she would say, well, we need new features instead of this cleanup project. Over time, this product scaled to an incredible amount of users, which made any new attempt at migrating off a forgotten technology much more difficult. Data that was supposed to be saved for regulatory purposes ended up falling off the end of a Mongo collection after 3 hours because somebody just forgot about it and the product scaled and they forgot to scale Mongo. So someone would come up with a new solution, they would end up with one more technology, one more temporary database with half-migrated data, and it stayed that way. That made the code base a lot more difficult to maintain, it made the stack brittle, it made the code base prone to outages. And because they didn't commit the resources early on in the project, they ended up with this twice as big of a mess. Okay, we know that cleaning up slows down developers in the short term, but it drastically increases productivity in the long term. To a decision maker, all of that might sound very time-consuming, but it pays off long term. I like to think of this as the not broken, why fix it philosophy. So the green line is a project that's taking technical debt seriously. It started out taking a little bit more time, but as time goes on, the cost of adding new features goes down. The red line is the project that didn't have a way of managing technical debt. It started out going much faster, but as time goes on, it takes longer and it's slower to add new features. The cost to add those features skyrockets. So you can show this to decision makers to tell them that it's worthwhile investing the time to tackle technical debt, because it can truly affect project velocity. If that chart doesn't work, you can also talk about the ski rental problem. So the ski rental problem, you're going skiing for an undetermined amount of time. It costs $1 or €1 to rent skis or 20 euros to buy them. Engineers choose between the risk of errors while working on an overly complex design versus reducing the complexity of the design before making a change. The extra cost of each change with the old design is the rental cost. The cost of fixing the issues is the buy cost. How many times do you work within a poor design before you invest in cleaning it up? Is a ski rental problem. There's another cost to all of this. Hiring developers is very hard. So is attracting developers to your open source projects if you work on one of those. Technical debt results in some very frustrated developers, and frustrated developers are a lot more likely to leave. Okay, well, you can't fix everything, nor should you want to. Some lingering debt is inevitable. This isn't an area that you can be a perfectionist in because tackling technical debt is a moving goal. Good decisions today might be bad decisions tomorrow. So, lingering debt is inevitable. Figure out what the project tolerance is for debt and then adjust accordingly. Use all of these arguments to justify the additional time that it will take to do things right. If you want to fully win the fight, you need to pay down your debt. So how do we do that? Refactoring is the single greatest weapon in your fight against technical debt. What is it? It is systematically changing the code without changing functionality, all while improving the design and improving readability. AKA a clearer way of saying the same thing. With refactoring, slow and steady wins the race, because the end goal is to refactor without breaking existing functionality. If you break existing functionality, it's a negative reinforcement that refactoring is bad and that it's not worth taking the time to do it. So replace functions and modules incrementally. Make sure you test as you go. Tests are absolutely mandatory at this point. If something breaks because of your refactoring, know that it's in spite of the fact that you took all the right steps. There are also a lot of great tooling available to help. Yelp Engineering, Yelp is a Python project. They did a huge refactoring with an in-house tool called Untitled. Untitled is a fast and reliable tool for performing massive automated code refactoring. It lets you define complex find and replace rules using standard readable Python. This can be applied to an entire code base with a single command. Yelp used it to remove 2 years of accumulated debt. There are lots of examples and sample use cases in the repo along to a link to this very interesting blog post. Another way to tackle debt is to use proper design patterns to decrease the amount of code and the complexity of the code. There's a great library called Python Patterns. It's an incredible collection of design patterns implemented in Python. You can just grab the code and mold it to your own use case. You can also use depreciation patterns, like OpenStack's debt collector. So they have a lot of helpful methods that help you remove code, depreciate code in a helpful way, like this removed property class. It's a property descriptor that deprecates a property. Works just like property, but instead it provides a warning that says this code is deprecated. Don't use it by the next version. You can also use vulture.py to find dead or unreachable code. It does this using static code analysis, which doesn't necessarily work well when code is called by introspection. And because Python is dynamic, Vulture can make a few mistakes, so it's very good practice to double check the results. But when used correctly, it can help you keep a code base clean by identifying dead or unreachable code. So I have some sample code here. I have 3 methods, foo, bar, baz. I called foo and bar, but not baz. And when we run vultr on this file, it tells us with 60% confidence that the function baz is unused. I think that's pretty cool. Make sure you prioritize. Figure out what is causing the biggest and most frequent pain points and work on that first. I worked at a company where one of the most critical components, the new user creation and login flow, was a 10-year-old piece of tech that nobody wanted to touch. That was the core of this code base. It was incredibly critical, but also incredibly brittle. So every new module that was created that had to use that system ended up writing its own wrapper around it, since nobody actually wanted to mess with the underlying code. It mostly worked, right? Well, that wrapper then turned into yet another piece of technical debt as more and more of them became created. I spent 2 or 3 weeks refactoring this code, breaking it down, testing it thoroughly, getting rid of all those weird wrappers, and I did it with tons of unit tests. I broke the process down into small and deliberate pieces and small functions instead of a monolith of code. I introduced this into the wild slowly with feature flags. Feature flags let me ramp up what percentage of users would go through the new flow versus the old flow. And it didn't go without a few hiccups, but the time was spent well overall. It meant that any new future project that had to work with that login flow or new user creation flow was then sped up, because there was one less component that was confusing and complicated, and they didn't need to go ahead and write their own wrapper for it. So just like with monetary debt, pay off the high interest loan first. Think about the shelf life of your application as well, because the shelf life of your project impacts the debt, affects the impact that debt has on it. Is your project around for decades? For example, that code base from the bank that I mentioned earlier? Well, put in the time to pay down technical debt and you'll get a huge return. If the shelf life of your app is 5 minutes, maybe you're working on the next Yo app. Did the Yo app make it to France? Yeah? Was there just one person on it? Okay, well, for those who don't know, it was an app on your phone that had a big button on it, and you press the button, and the app would say, Yo. It was incredibly popular for like a month or two, I don't know. So maybe if you're working on the Yo app, devoting the time to tackle technical debt is not all that important, right? It doesn't matter. If you don't know the shelf life of your product, maybe err on the side of being conservative and do pay down your debt. It's very situational. You can't always guess. But technical debt can also be strategic. Just like with monetary debt, if you don't have to pay it off, well, then you just got something for free. If you're building a system and you racked up a ton of debt and you got acquired before the technical debt started affecting the product, well, maybe you just won something there. Technical debt can occasionally also be used as a tool when you know you don't have to pay it off, like that Yo app. Making the time for refactoring depends on a lot of factors, including the size of your team and the size of your problem. Rule of thumb, just a general rule of thumb, of course, adjust as necessary, but know that your project estimates should always account for the additional time that it takes. If you have a small team, maybe consider devoting a week every 6 to 8 weeks. If you have a medium-sized team, maybe devote a person every 1 to 4 weeks. Make sure you rotate so that person doesn't slowly start going insane. Right? Because technical debt is a team-wide problem. If you have a large team, maybe consider 1 week every every 4 weeks or so. Maybe everyone on the team can chip in and contribute. Okay, a few last tips here. Code should be for humans. Your code interfaces with the machine eventually, but at the top level, your code needs to be human readable. So focus on good variable names, good method names. Brandon Rhodes is an incredible speaker and has a great talk about duck typing. I will tweet out a link to his talk after this one. It's one of my favorites. Make sure you be clear instead of being clever. Leave comments, write tests. Be mindful of the person reading and maintaining your code, because sometimes that's just you a few months later. And I like this rule. The Boy Scouts have a rule. They're an organization in the US that takes little kids camping and teaches them wilderness skills and all of that. And they say, always leave the campground cleaner than you found it. Uncle Bob Martin, who's written a lot of incredible books on development, also has a rule. He says, always check in a module cleaner than when you checked it out. I really like that rule. Remove those unused imports and variables. If you see a commented out chunk of code, now you have the resources to find it later. Delete it. We have version control. If you have that heaping pile of trash for a code base, maybe instead of dropping that broken bottle on the very top, you take something off instead and clean it up. That makes the code base so much more pleasant for the next person. But expect to be really frustrated in this process. You're cleaning up after days, months, years. If you work for the IRS, maybe decades of bad decisions. It might feel like you're untangling a giant ball of yarn. It might feel impossible, but don't give up. You can do it, all of you, with patience, with perseverance, with a little elbow grease. You can tackle off your technical debt because it'll pay off in the long term, and the results are so worthwhile. It's been a pleasure speaking to you today. If you want to learn more about Python at Microsoft, check out this link, bit.ly/ParisPython. We have so many great things to offer, like the Python extension for VS Code. We have hosted Jupyter notebooks, Azure notebooks, and a ton of Python support all along Azure. If you'd like to learn more, please find me after this talk. You can follow me on Twitter at NJA. I've posted the slides for this talk there. There's a lot of links and little Easter eggs to follow along with. Thank you all so much.
Thanks a lot, Nina. It was a wonderful presentation. Maybe one or two questions. You have a question? Yeah.
Oh, yeah.
Hello. Thank you for your talk on technical debt. I know a little the subject because I work on an older project about auditing old app programmed 20 years ago in C, C++, and I use Python to audit the code. And it's interesting to see that there is something about technical debt now in Python, because maybe Python is going to be the next COBOL, I don't know, used for 50 years. And my question is, for me, the technical debt, you spoke about internal case about technical debt, the code that you produce, the team, and so on. But for me, there is another source of technical debt, is the open source software development, where we produce code that relies on libraries. And every day, every week, every month, the libraries are evolving. And when you try to reuse the code that has 3 months, one year, 2 years, it doesn't work anymore because you change your environment, the API has changed, and so on. And for me, do you call that? The question is, do you call that technical update or not? And what is the way to tackle the fact that when you take 2 years old code, it doesn't work anymore because everything which relies for which the code relies on has changed?
Yeah. So I have a few strategies here. The first is make sure you're pegging your dependencies with versions, and that will prevent your code from breaking as new versions of the code gets introduced. You can do that in your requirements.txt file. You can also use pipenv and make sure that you specify a version. The next thing that really helps that is documentation. So documenting each and every step you take to have your code base in a working version. I think with those two things combined, you should hopefully not have as many problems. Of course, there are always APIs that become deprecated or have breaking changes, but Facebook is one example. They kind of always have a moving target. But if you peg your dependencies, if you create documentation, and if you find that this code that's depending on these libraries is important, you can also make time to check on it periodically and do maintenance and check for any broken APIs or broken changes. Yeah.
Thank you. We have time for another question.
One more.
Yeah, thank you. It was great to hear all the things you said. I applaud.
Thank you.
I retweeted that, as you wanted. But I have one question. You mentioned the importance of leadership, management, of embarking people like this.
Yes.
But what about individual coders? Because, or non-coders, but who do program, like data scientists, etc.
Yeah.
Maybe they don't like, maybe they're not interested in writing good code. How do you have ideas for helping with that?
Yeah, I think understanding the value of maintenance and fixing technical debt is something that comes to a developer with experience. I don't know anyone who's been in the industry for 5 or 10 years who doesn't think that any of this is important. So I think part of your solution there might be having a mix of senior and junior engineers, making sure that there's mentorship available. Because like I said earlier, when I first started out, I just wanted to be seen as a good developer, and good developers ship code. And I didn't realize that there was kind of a whole ecosystem of problems that I could introduce with that attitude. So mentorship, knowledge, training, you can share my slides, is really important in solving the problem.
Okay, maybe one last short question.
In the green shirt, yes. Sorry to make you run.
Thank you for a great talk.
Thank you.
What advice would you give to, say, a new engineer who is starting in a new team? Maybe she saw your talk and she's starting to realize about technical debt, but in the team, the other people really don't have the culture about technical debt. There is some technical debt in the project. But so what is the start really to fix things? Is it at the team level? Is it at the individual level? Because I think a lot of people are facing this, but they don't really know how to start.
Yeah, there's a few different strategies you can take. If you want to try to tackle it individually, you can take inventory of those issues in your code base that are causing the most difficulties, the most problems, and maybe sort them and figure out which one would be the least effort. Do you end up having time during your sprints to work on maintenance, or not really?
It was a theoretical question.
Theoretical, okay. Not actually about you. Got it. Yeah, it can be a really hard sell. I feel like having big, important wins first really helps kind of drive in the point. When developers start seeing that parts of the code base are a lot easier to work with and that they're getting paged less, that's kind of a big one. That's the big way to sell this to other developers as well, is less off hours, less fires in production, less emergencies, and more free time to spend walking around Paris.
Thank you.
Thank you.